This is a review of the Dr.Meter HY3005F-3 triple linear DC power supply. It features a dual output of 30 volts DC at 5 amps that is adjustable, and it also has a constant voltage source of 5 volts rated at 3 amps. The unit comes with a AC power cord. It's 72 inches long, which is 6 feet, and it also comes with a set of test leads to attach voltage. These test leads are 39 inches, or basically 1 meter in length. In addition, you get a brief user manual and also a warranty card. The warranty on the product is 12 months. The first thing you'll notice is that it has a very nice and clear display. There are 4 displays here: amp and voltage for the slave channel, amperage and voltage for the master channel. These are the adjustments where you can adjust the current output and the voltage output. And then these are the current and voltage output for the master channel. You'll see here the minus and plus outputs for the 2 channels. And you do have a chassis ground here if you need to hook it up to your circuit. Here you see the power switch. When I push it, you'll hear the unit click. That's because there are relays inside of it, and the relays are energized to select the right secondary tap off the transformers. You can also take this master channel and the slave channel and adjust how you use them. You can use them independently as 2 different sources. You'll see here I can adjust one of them, for example, to 12 volts. And then I can take the other one and adjust it and set it for 30 volts. And once that's done, I can power 2 devices at 2 different currents, or 1 device that requires 2 currents, and then I can take it and also adjust the current output and voltage output of each device. You also have a 3rd channel here. This 3rd channel is a fixed channel. It's plus and minus 5 volts DC, so it's 5 volts DC with an output of 3 amps. My only negative of this device so far: it's beautiful. It's easy to use. It's easy to set up. It's very accurate in its voltage output. I'm just surprised you only get 1 set of connection leads. I know they're expensive to put together, but you know, if you got 2 outputs or 3 outputs, 1 set of leads isn't going to cut it. So you're going to have to immediately go out and buy some more. I want you to know I don't have my oscilloscope anymore. I didn't use it very much, and so I gave it away. But here we have the adjustments, and I'm going to use a Fluke multimeter to check the voltage outputs and show you how accurately they can be set. Because I don't have an oscilloscope, I asked the supplier, hey, how do I know what kind of test you put this thing through? They sent me about a 40-page document including test procedures and photographs of how this unit is tested in the lab, and it's impressive. They do things like voltage regulation, harmonic current testing, high pot testing, electrostatic discharge testing to affect the outputs. It goes on and on and on. Let me just assure you that from what I can see, this thing is well designed and it's very solid. I'm going to take this here, and you can see here that I have this set at 12 volts. I'm going to set this in here, and you can see it's exactly 12 volts, right on the money. And in my adjustments of these different ranges here, I found them to be very, very accurate. There's 15 volts. My Fluke meter says it's 4/100ths of a volt off. You heard the click. That means I've jumped to another tap on the transformer. The relays made that switch for me. Here's another one. I can adjust this to 20 volts. And as I do that, you can see I'm 19.95. I can also tell you that I can take this here, and this is the master channel. If I tell it that I want it to go in series, it will lock the 2 in series, and whatever the master channel is set at, the slave channel is going to match it. So you see it jump up to 29.8. I'm going to adjust that to 30. And right there you see them both set at 30. Now I'm going to check the voltage from the minus over here to the plus over here. And you'll see I'm reading 59.8 volts because the voltage is now in series. I now have doubled the voltage. So if I want to get more than 30 volts, each of these is adjustable to 30, I can put them in series and basically get higher voltages if I wanted, or I can push the other button and put them in parallel and get higher current outputs. So it makes it very functional, and if I want, if both these buttons sticking out, I have them now set on independent mode. The two channels are independent. So in reality, you can get three different voltages here, whatever you want to adjust here, whatever you want to adjust here, and the 5 volts DC at 3 amps over here. Here you can see I have it set on 5 volts. I'll check that with my multimeter here. And you can see I'm at 5.03 volts. Now what I'm going to do is I'm going to set the current of this. I'm going to take the current and crank it all the way down. I'm going to plug this in. I've shorted the minus and plus. I'm going to adjust this up and set this for a max output current of 0.5 amps. When you do this, you want to make sure that your wire is capable of carrying that current. Now that I've done that, I can unplug this, and now I've set this to have a 5 volt output at 1/2 amp. So that's one way you can adjust the voltage and current. If you have a test bench in your garage, this is the kind of thing you're going to need to use it. It's ideal for checking out all types of equipment and connecting it up, whether it's radios, devices out of a car, crank it up to 12 volts and power it up. You can even do things like a computer component that requires 5 volts and 12 volts, for example. Very functional, very easy to set up, and very easy to operate. As I've shown here, I've also found these displays on the front here to be very accurate. Like I say, it says 5 volts, and if I hook this up here, you can see I'm reading 5.03 volts. So very accurate, very easy to set up. It's quite a nice power supply. I wanted to take the lid off to show you how this was put together. I was amazed at how heavy this was. This is a robust piece of equipment. And as you can see inside it, that's a massive transformer with multiple taps to give you all the voltages you need. Inside of here, you have a display board in the front that's mounted into the front panel. And on the side here is one of the channel output boards. Here you can see the relays I was talking about. You could hear them clicking as I made the adjustments. Those relays help get the right taps off the transformer to feed power back to the voltage regulators. This is one board. There are actually two of these boards that are identical, one on each side. On the back here you can see a couple of massive heat sinks. That's where your voltage regulators are mounted to help dissipate the heat. And in the time I've been using it and testing it and using it on items, you can see here that it's quite well made and it didn't get hot at all. So that heatsink did a great job. Down here in the bottom, that's a little separate voltage regulation circuit to power the 5 volts DC at 3 amp output. It's wired to the front panel to supply the voltage and current for that channel. I just wanted to point out that back here on the plug, the fuse is in here. So if for any reason, if you ever blow a fuse, you replace it in here. Just to make sure that you replace it with the same amperage and the type. I like this power supply a lot. If you're building a test bench for your garage or a laboratory, it's a good piece of equipment. It's priced right and the quality looks pretty doggone good. The case is all metal except for the front panel, which is a plastic panel, as you can imagine. It's nicely designed. I like the display. It's very easy to set up and adjust the voltage and current. I do want to point out that I did weigh this power supply. I told you it was heavy. It weighed 20.2 pounds, so it's quite heavy. I rate this product at 5 stars. This review was done by JJ CEO. I'd like to know you received a sample for test and evaluation, and I didn't promise a review, but I promised if I gave one it would be fair and honest.